Greetings. My name is Sipesihle Gama, student number 2200213556. Today I'm going to carry on with my lesson under the electricity and magnetism. On my previous video, we talked about, I was introducing the topic and I explained everything, and there's some subtopic under this topic. And today we'll be focusing on triboelectric effects under electrostatics. As we said, that if we talk about electrostatics, we talk about static. Static means not moving, which means it's electricity which is moving under one, which is not moving, meaning that it's moving under one material or anything. For instance, as we know, electricity involves two charges which are positive and negatively charged. So today we'll be talking about the materials and how the charges are being, because I think the first thing that we have to know is that each and every material have its own properties. For instance, some they tend to lose electrons. Electrons are the charges which are negative and protons which are positive. So for instance, we have those materials which are good conductors of electricity, as I'm going to explain that now. And there's this thing that we have to know, this: if you rub two objects or material, some it tends to lose electron and some it tends to gain electrons. As we know that that's what is going to happen if we talk about the charges, because we know that protons, which is a positively charged, they tend to stay on that material, but what usually moves is electrons. So due to the nucleus of the material or the protons, so we have nucleus which involves neutrons, which are neutral. So now I'm going to be using simulation, PhET simulation under physics. So I'm going to include blended learning on the class using the simulation. I'm going to demonstrate how they work and how the materials lose electrons or gain electrons, which emphasizes. I'm also going to do some examples. So now I'm just gonna go through my lesson plan as I've prepared, so that everything is gonna go in order. Unfortunately, I'll have to use the laptop to demonstrate the PhET simulations. Mostly of my lessons is gonna be based on the laptop and the use of PhET simulation. So I'll be using, if I was in class, I was gonna use a projector or anything, but now since there are no learners, then we're gonna make some examples. But I'm going to firstly explain the theory under electrostatic, which is triboelectric charging. So now I'm just gonna go through my PhET simulation. I'm just gonna highlight on my development. I'm just gonna explain what is triboelectric effects. Then after that, we're going to do some examples. Then after that, we will be answering some questions, just few questions with the class. So I'm going to start now, just making the definition and explaining my lesson plan. So our today lesson focuses on electricity and magnetism, which is gonna go under electrostatics, which is triboelectric charging. CAPS page number, it's 40 to 41. So I'm just gonna go through the development because the video is mainly focused on the development. Okay, so as I've said that I've explained, but I'm just gonna go through here just to explain everything. Okay, the triboelectric effect is a type of contact of electrification on which certain materials become electrically charged after they are separated from a different material with which they were in contact. As I've said, that if the materials, they become in contact, so some of between those materials, one of which is gonna lose electrons or is gonna gain electrons. This depends on the triboelectric series where it stands. Some are positive, they tend to lose, and some they tend to gain electrons. So now I'm just gonna go through here. As I've said, I'm just gonna explain everything. Objects may become charged in many ways, including by contact with or being rubbed by other objects. So in that, as we go on with the lesson, we'll include friction force. That's how it happens, because they must rub each other. So under that, as we know, that's gonna energy from friction force, we end up to gain heat. After you rub something, even if you can rub your hands, you can feel that there's heat. So energy was lost, but it wasn't lost, it was changed, it was converted. As we know that energy it cannot be created or destroyed, so it was converted to heat energy. So but we're just gonna go through those topics. We are still focusing on the charges now. This means that they can gain or lose negative or lose electrons. For example, charging happens when you rub your feet against the carpet. As I've said, I'm going to explain this and I'm going to show it on the PhET simulation and example how it happens, how that happens. When you then touch something metallic or another person, you feel a shock as the excess charge that you have collected is discharged. So that's what I was explaining here. So if maybe one of the material was charged, it's either it was positively or negatively charged. It's either going to gain electrons or it's going to lose electrons. But when it gets in contact with another object, it's going to depend if it's either that object is negatively or positively charged. So it's going to transfer those electrons which are needed by that object. So every time, even if you remember, if you touch especially in winter, when you touch the blanket, there's some sparks happening there. It's the movement of electrons. So even if you touch something or metallic, as they said here, even if you touch the door handle, sometimes you can hear that, you can feel that there's electric or there's that spark that you feel sometimes during the humid conditions in winter. So I'm gonna go through here we're going to explain the materials in their rank, how they tend to gain or lose electrons. So I'm just gonna go through here due to the time limit that we have here. The triboelectric series is a list that ranks materials according to the tendency to gain or lose electrons. As I've said, it's either it loses electrons or gain electrons. The process of electron transfer is a result of two objects coming into contact with one another and then separating is called the triboelectric effect, triboelectric charging. In the triboelectric series depicted below, materials are ranked from high to low in terms of the tendency for material to acquire a positive charge. So here I'm just going to try to zoom out this image so that you're able to see it clearly. So here, this triboelectric series here, these materials at the top here, you see they tend to lose electrons. So you know, if you lose electrons, that material is going to be positively charged. So they talked about rapid fire. It's rapid fire. It's on the skin of the rapid hair tend to lose electrons also. The glass, mica, wool, all these material, they tend to lose electrons. So what I'm going to do example of it with the PhET simulation, I'm going to be using wool, and I'm going to be using the wrap the balloon on the wool. It's a jersey. Okay, these ones at the bottom here, these materials, they tend to gain electrons, which is silk, paper, wood, amber, rubber balloon, polystyrene, you know, it's plastic, acrylic, and polystyrene and Teflon. So now I'm just gonna go through here. This is an example. Where does the negative charge come from when a balloon is rubbed against a jersey? the negatively charged, they come from the jersey. You see here, the jersey is usually made of wool. So if you wrap a roller, a balloon, you see the balloon, it ranks under the negatively charged ones. So it takes the negatively charged electrons from the wool when you wrap them both. So example, okay, here when a balloon is wrapped against a jersey, you see, so we've answered that question. It takes the negatively charged electrons from the wool. So when you wrap a balloon on a sweater, for example, some electrons come off and end up on the balloon. The fibers have lost electrons from the jersey, electrons giving them a positively charged. The wrapper gained, which means it gained what? It gained the balloon gained what? Gained electrons. So gained electrons, as I've said, giving it negatively charged. Since the electrons have a negatively charged, the balloon now has a negatively charged. It is negatively charged. Okay, now we will use some PhET simulation resources to show the transfer of electrons with the learners. So now what I'm going to do, because I've already opened them due to the time, I'm just gonna show some example using the PhET simulation. Then the learners will be using the PhET simulation, which is under the blended learning, where we use the technology in demonstrating and making examples. So I've decided to use the PhET simulation under physics. So here are the links, I've just included them here. So now I'm just gonna play the PhET simulation. Here is our PhET simulation. So it's like this at first. As we said, that it ranks the balloon, it ranks under where they usually gain electrons, and the jersey at the top there, we remember I've said on the triboelectric series, as I've said here, we have to go, because this is important. You know that when I wrap it's a wool, the jersey is made up of wool, and the balloon is made up of rubber balloon. It's under the negatively charged, which means it tends to gain electrons. So the wool tends to lose electrons. So I'm just gonna play my PhET simulation. So now I'm gonna wrap, the balloon is neutrally charged. Even the jersey is neutrally charged, you see. So when you wrap there, here is just the wool, but nothing is gonna happen here. I'm just gonna go through the PhET simulation. Here's my balloon. Okay, if you like, they can make the balloons become two. So I've just decided for now to use one balloon. So this is how the PhET simulation works. So now we said show all the charges. So we have to prove that what they said here is gonna happen. So now if you wrap the balloon on the jersey, you see what is happening. If you see here, the balloon gains what? Electrons. As they've said here, under here, you see it wants to gain all the electrons here. You see it's taking all the electrons. As I've said, you see now it wants to go through the jersey. So I want to reset the balloon. Now the charges are what? Are neutral again. So I'm just gonna add another balloon just for the interest sake of the experiment. So if you take this, you see it gains electrons. So now due to the negatively charged, this jersey, it's gonna the balloon is gonna be attracted to the jersey due to that it wants to be neutral. So if you leave it like this, you see, automatically, even if you can take this one here, it's gonna do the same thing. It's gonna want it's gonna want to gain the electrons. You see, it's gaining the electrons. So as I've said here, I hope the experiment or my practical view, the learners, they can also do the same thing, or even they can reset and just use one balloon here just to see. You see, it have gained electrons. How many electrons they have gained? It have gained 1, 2, 3, 4, 5. So this thing, that's how it works. So we're just gonna go back to our, as I've said, you see, it's usually the balloon tends to gain electrons, and the wool tends to lose electrons. So now I'm just gonna play another PhET simulation just for the interest sake of the learners. Here's another PhET simulation here. Okay, sorry. Okay, here's another Phet simulation here. You see here, this person, it's a person and a mat. You see, as you wrap here, as I've said, friction force, this person do what? Gains electrons. So if he touches here, because this is a door handler, it is electricity conductor, a good electric conductor. You see, if you do here, the electrons are being transferred here. So if you wrap another Phet here, as you wrap the Phet here, he gains the electrons. This man gains the electrons, and now due to he is negatively charged. So his body is going to, or the wool on his body, it's going to want to be neutral. So in terms of that, because since it's negatively charged, this person is going to want he have to be neutral. So you have to lose some of these electrons. So when it touches the door, there's a electric spark. As I've said, there's electric spark. You remember, even if you're at home, it means you have gained electrons, and when you touch the door, there's a transfer of electrons. So yeah, I think now the learners using blended learning, I think they've seen some examples. Now we're going to answering some few questions with the learners here. I've included the activities, activity 2. So now when you, okay, we've done this with the learners, but we're just going to go through the questions, both of us. Here's the question: when you wrap plastic and the wool together, I think everyone should be clear now what is happening. Which particles are transferred from one substance to another? So as I've said, the particles which are transferred are electrons. Are transferred from the wool to the plastic, as we've seen that the plastic became negatively charged. Which substance will lose electrons and become positively charged? It's what? It's the jersey, as I've shown here. It's the jersey, because if you tend to move here, it's gonna be positively charged. They are more positively charged because they are taken by the balloon. So it's simple. Since we've done this, so it's gonna be what? It's which will lose electrons. It's the jersey. So it becomes positively charged. So which substance will receive electrons and become negatively charged? Obvious. It's what? It's the balloon that is the balloon that is gonna be the plastic roll. Because if you remember the balloon, because it's a plastic, is made up of plastic, so it's why it tends to become negatively charged because it gains electrons. And even if we go here on the triboelectric effect, what happened here, the balloon, it gains electrons, which means it becomes negatively charged. So yeah, so I think we are done. We have done our lesson, and then on the second lesson we'll be putting more the worksheet where the learners will use, because I left the simulations here, so it's gonna be easy for them. They also have to use the triboelectric series which have the material. So I think my lesson was successful. So as I've explained here, that's how we have included our blended learning. We can do some more examples, but due of the time and the lesson, the learners, they can, because I've included the link, the learners, they can do some simulation on their own, since I've shown to them what is happening. Even if we were doing the activity here, it was simple because they were able to, the simulation, they were able to help the learners to answer the questions. Thank you.